I don't know how much of that. I don't know how much of that got caught, but at least the work is there. Dang. All right. How about this? Let's name and draw this compound. First of all, is that HCIO or HCLO? Yeah, but it is really terrible how capital I and lowercase l look in a lot of different places. Type of compound. Is it ionic, covalent, or more specifically, an acid? Alina nods her head. Yes. Good. You think that because you guys recognize it. You've worked with it. What else might give it away that it's an acid? You know what? The H is actually not bonded to the Cl. The H is bonded to the O, which is one of the reasons we call it an oxyacid, because it's going to be an OH bond. But generally, when hydrogen is written at the front of a chemical formula, those are often acids. There is one acid that's incredibly common where the H is actually written at the end. You guys are going to deal more with acids and bases in the second half of the semester and a lot more in Gen Chem 2. One trick that we often tell people is look for OH at the end of a chemical formula to represent a base, and look for H at the front of a chemical formula to represent an acid. But this is actually not OH. It's the acidic H at the end. It's terribly confusing. But this is a chemical that you've all ingested at least once in your life, I'm sure. You guys remember the name of this? It wasn't. I'm just glad it wasn't loud enough for the camera. Vinegar. And its chemical name? It's got acid in it. Vinegar acid. No. This is one you guys need to know. Maybe you're used to seeing it written a little bit differently. Oh. Maybe you know its polyatomic ion form, which you need to know for the exam. Starts with an A. This is acetate, and this is acetic acid. Remember what we said about eights becoming ix? I won't say it again. It's on the internet. You can go find it forever. All right. So that was just kind of a tangent, right? Most of our acids have hydrogen written at the front. So that's usually a quick place to look to see if you have an acid or not. Because it's an acid, we know that we can take its ion name and then change its suffix and add acid after in order to get the name of the acid. So can you tell me what ion this acid is formed from? For instance, acetic acid is formed from acetate. What ion would we have here? Even if you just want to spell its chemical formula. What did you say though, Ashley? No, chloroxide is not a bad guess, but it's not its name. What about the chemical formula of the ion? Sorry? ClO neutral? Sorry? You're right. What's that chemical formula? ClO minus, which is actually easy enough to guess. Remember, we took an H off of acetic acid and we were left with a minus. Hydrogen likes to take on what charge, given its place in the periodic table? +1. So if I remove +1, I'm left with -1. All right, with all of the halogens, I want you to be familiar with this oxyanion family. So the lowest number of oxygens you can get on the halogens is just 1. That's going to get a prefix hypo. Hypo meaning cold or less than, right? And then we've got chlorite. Because ite, similar to last time, ite was telling us, again, less oxygens than the other versions. So this is hypochlorite. If I put as many oxygens on here as possible, that's going to be 4. What do I call this? Perchlorate. Good. Hypo changes to per. Ite changes to 8. And then I've got 2 in between. What are the 2 in between? Chlorite and chlorate. I've got hypochlorite, chlorite, chlorate, perchlorate. You know, hydrogen peroxide is named peroxide for the same reason that this is called perchlorate. Hydrogen peroxide has 2 oxygens, which if you think of that relative to water, it's got more oxygens than water, so it's a peroxide. That's how I think of it. What would happen if I changed this to IO4 minus? Can you give me the name? Correct. Periodate. And if it was BrO4 minus? Perbromate. Exactly. So with chlorine, bromine, and iodine, you should be able to recognize the naming pattern. You just swap out the front part. Here's a fun acid. What is the name of HIO4? Oh, actually, we didn't even finish this one either. Let's start with this one. What would we name this acid? If 8 turns to ick, then ite turns to us. So the name of this acid is and then at the end, hypochlorous acid. Hypochlorous acid, HClO. Quite a long name for a very small chemical formula. And then could you name periodate as an acid? Berkeley, you think it's called periodic acid? It is. Periodic acid. Spelt the same as periodic acid. It's one of the fun word plays in chemistry. One of the only fun word plays. I want to draw periodic acid and hypochlorous acid. Remember that the hydrogen is going to be bonded to one of the oxygens. One of the reasons they're called oxy acids. So ClOH IOOO and H. Would you agree that this is a good way to start setting up their structures? Okay. What else do I need to do in order to build their Lewis structures? Single bonds, always. Oh, how many electrons did I just use? How many electrons should I use? I need to calculate how many valence electrons I can have, right? And charges play in here. If I have a positive charge, I actually have less electrons than expected. If I have a negative charge, I have more electrons than expected. So that's 7 plus 1 is 8 plus 6, 24 electrons here. And here I've got 6 times 4, 24, plus another 8, 7 plus 1, so 32 electrons. On top, so far I've used up how many? 4. So I've got 20 left to plug in, and I'm going to plug those in as lone pairs. 2, 4, 6, 8. Did it? Yeah. What did I do wrong? I don't know either, but I went from 8 and 6, I went to 24. 8 and 6, it is 14. Too bad I didn't use my calculator for that. Don't be ashamed to use your calculator for those things. It's okay. I would have realized something didn't make sense eventually. So I've got 10 electrons left. 2, 4, 6, 8, 10. Great. Here I've got 32. Well, I'm not going to lie. These oxygens are mostly going to have lone pairs here. And we can kind of go from there. I'm running out of time. Actually, I've run out of time. What I wanted to do, though, was quickly wrap up how we can look at octet and hybridized orbitals. Remember that we can look at electron regions to predict hybridized orbitals. So around O, 1, 2, 3, 4 electron regions. I'll need S, P, P, and P to get there. And so the oxygen is sp3 hybridized. We'll come back to this one tomorrow because if we calculated formal charge on this structure, we would find a lot of formal charge. So we'll see how we can minimize formal charge on Wednesday and then look at hybridizations there again. I'll keep you guys updated with Canvas. As soon as I have access to Canvas again, I'll message you guys. If you haven't taken the Unit 3 to 5 test yet, and I may end up pushing the due date for it because I don't know when it will be accessible. Like if you haven't taken it, that's not really your fault. You were still planning on taking it. So I'll make sure that we all have the ability to. And I'll keep you updated with the testing center. If you have to be rescheduled, I really apologize for the inconvenience. We'll make it work. I know it's stressful, but don't worry about your grade. We'll make it happen.
So you kind of just went over it.